Hi, welcome to solveandgo.com. In our video today, we're going to talk about limits of rational functions as the variable, in this case x, approaches plus or minus infinity. Before we start talking about the limits, we need a few key notions. So the first is that of a rational function. A rational function is a quotient of polynomials. So it has the form r of x equals p of x divided by q of x, where p and q are polynomials. We also need the notion of the degree of a polynomial. The degree of a polynomial p of x is, by definition, the highest power of x occurring in the polynomial of x in the polynomial p of x. Okay, so for example, the degree of x cubed plus x plus 1 would be 3. Okay. When considering limits of rational functions as x goes to plus or minus infinity, there are three cases. And these have to do with the degree of p and q. So again, r of x is the form p of x over q of x. And there are three cases. The first is when the degree of p is bigger than the degree of q. The second is when the degree of p is less than the degree of q. And the third is when the degrees are equal. Okay, so in each of these cases, we get a different type of answer. So let's take a look at case number 1 first, and we'll do so basically by example. So case 1, we have the degree of p is bigger than the degree of q. Okay, in this case, what we get is the limit. So again, let me remind you, r of x is p over q. In this case, the limit, as x goes to plus or minus infinity, is going to be plus or minus infinity. Okay, let's take a look at an example and how we can determine whether this limit is plus or minus infinity. So what we have in this case, the limit is x goes to infinity of negative x cubed plus 1 divided by 2x minus 2. So in this case, the degree of p, negative x cubed plus 1 in this case, is 3, and the degree of the polynomial in the denominator, 2x minus 2, is 1. So we fall into this case where the degree of the top is bigger than that of the bottom. And the rule for all of these cases here is that we'll be taking the leading term in each polynomial, so the highest degree term, and forgetting about the rest. So we take negative x cubed over 2x. What happens here is we can divide the top and the bottom by x. And what we end up with is negative x squared. And as x goes to positive infinity, negative x squared goes to negative infinity. So the coefficients in front of the leading terms, again, the leading terms being the highest degree terms in the polynomials, are going to determine whether we have a limit of plus or minus infinity. Let me do one more example. Take the limit as x goes to negative infinity of x to the power of 4 plus 2x plus 1 divided by x cubed plus 2x squared plus 2. Here again, the degree of the polynomial on top is 4. The degree of the polynomial on bottom is 3. So here, again, we're going to take the quotient of the leading terms. We get x4 over x cubed. Okay. Canceling common factors of x from the top and the bottom, we're left with just x. Now x is going to negative infinity, so the limit of x in that case should be negative infinity. And that's case number 1. Case number 2 is when the degree of the denominator is bigger than that of the numerator. So again, we have a rational function, r of x is p of x divided by q of x. And the case here is the degree of p is less than the degree of q. Okay, in this case, the limit as x goes to plus or minus infinity of a rational function is going to be 0 always. All right, let's see an example. We'll take the limit as x goes to plus infinity of x over x to the power of 10 plus 2. Again, we just consider the leading terms. We end up with x over x to the power of 10, which is the limit as x goes to plus infinity, 1 over x to the power of 9. And as we've seen, 1 over x to any power goes to 0 as x goes to plus or minus infinity. So the answer here is 0. Okay, one more. In case 2, take the limit as x goes to negative infinity of x to the power of 3 plus 4 over x to the power of 4 plus 1. Again, just take the leading terms. We get x cubed over x to the power of 4. And what we end up with after canceling factors of x is 1 over x, which as x goes to negative infinity approaches 0. Okay, so in this case, we always get 0. Okay, case number 3 is when the degrees are equal. All right, in this case, the limit is going to be some finite non-zero number. Equals c, so c is a finite, so not infinity, non-zero number. Okay, we get this number again by just considering the highest power terms in the polynomials. So let's take an example. X is approaching infinity. We're going to take 3x cubed plus 2x plus 1 divided by 4x cubed plus 3. Here, the degree of the top is 3, and the degree of the bottom is 3 as well. Okay, so here we take the leading terms. We get 3x cubed over 4x cubed. The x cubed factors cancel, so we get the limit as x goes to infinity of 3 over 4. And since there's no occurrence of x, I erase something, let me throw it back in. This is a 3. So since there's no occurrence of x, this limit is just 3 over 4. So we get a finite non-zero number, 3/4 in this case. One more example of case 3. Take the limit as x goes to negative infinity of negative x plus 2 divided by x plus 1. Okay. Again, the highest power of x in the numerator is 1, and it's also 1 in the denominator, so the degrees are equal. We get negative x over x, which after canceling x leaves a negative 1. Okay, that's the answer, negative 1. Okay, so those are the 3 cases for limits of rational functions.